You hear all the time about the incredible power of AI, right? But have you ever stopped to wonder what it really takes to build one of these massive language models from the ground up? Today, we're going to pull back the curtain, using the small training playbook to get into the messy, hands-on, and often chaotic art of pre-training. Okay, so first things first, let's just bust a huge myth right now. The popular image of building AI is all clean rooms and predictable science. You know, like you're just following a perfect blueprint. But the reality? Oh, it's way more like being a master chef in a super chaotic kitchen. It's a messy, iterative, and deeply experimental journey.
And I'm not just being poetic here. Pre-training is not some smooth, automated process that you just press a button for. It's defined by very, very human moments. We're talking 2 a.m. debugging sessions, these sudden performance drops they call loss spikes, and subtle little bugs that can completely derail weeks of work.
And when you're working at a massive scale, the problems don't just add up, they multiply. We're not talking about small hiccups. Teams run into crazy issues like vanishing throughput, where the data just mysteriously slows to a crawl. Or they'll find these tiny bugs in how all the processors are talking to each other that are almost impossible to find. Any one of these things can easily turn a month-long training run into a 2-month marathon.
So, this all leads to the big question, right? If the whole process is this unpredictable and this chaotic, how on earth do the builders manage to steer these models into becoming something useful and intelligent?
The answer, and honestly, this is probably the most important thing to take away from all this, is that it is all about the data. The playbook is crystal clear on this. Data curation, which is just the process of choosing and balancing the information the model learns from, is the single most influential part of training. It's even more important than the actual architecture of the model itself.
Think about it like this. If training a model is like baking a cake, the model's architecture is the recipe, right? But the data? That's your flour, your sugar, your eggs. And the real secret to a great model is what the builders call the data mixture, that precise combination of all your ingredients.
So let's make that a little more concrete. Here is the actual starting data mixture for a model they call small LM3. As you can see, it's not just one thing. It's a carefully measured blend, mostly general English web data, but with important slices of multilingual content, code, and even a little bit of math. This is the starting recipe.
But here's the catch. Getting this mix right is incredibly hard. It is a super delicate balancing act, mainly because each type of data is kind of competing with the others. For example, you might think, hey, let's just dump in a ton of code to make the model a coding genius. But the playbook found that if you add too much, you can actually hurt its ability to do general reasoning in plain English.
So, if your intuition can lead you astray, how do you find that perfect balance? Well, they use a method called ablation-driven experiments. Now, ablation is just a fancy, sciencey word for taking something away. Instead of just guessing, they systematically test different data proportions, add a little more of this, take away some of that, to see what actually works.
And this leads to this really brilliant and efficient technique called an annealing experiment. Instead of training a whole new model for every single test, which would cost a fortune, they do something much smarter. They pause the main training run, they basically branch off a copy, and they train that copy for just a short little window with a new data mix. It lets them quickly taste test a new recipe and see how it turns out.
I absolutely love this analogy from the playbook because it just clicks. They say it's like you're a music producer tuning a soundboard. You don't record the entire album to see if the bass is too loud, right? No, you play a short piece of the song at full volume, you tweak the levels, and then, once the mix sounds perfect, you hit record on the whole track.
And here's a perfect case study of how that works in the real world. The team's first guess, their hypothesis, was that a 25% code data mix would be great for reasoning. But their annealing experiments showed it actually wrecked the model's performance on English benchmarks. So based on that hard evidence, they dialed the code way back to just 10%, which kept the model's general skills intact.
So they found the right balance for that moment. But this is where the real artistry, the master's touch, comes in. Because it turns out the perfect recipe isn't static. The best model builders don't just find one perfect mix and then call it a day.
No, they use what's called a multi-stage training curriculum. And it's pretty much exactly what it sounds like. It's the strategic process of actually changing the data mixture as training goes on. It's just like a school curriculum. You know, you teach a student basic math before you throw calculus at them. You teach the model different skills in a specific logical order.
The whole philosophy behind this comes down to recency. The data a model sees toward the very end of its training has the biggest, most powerful impact on its final behavior.
This makes that last phase of training the most valuable real estate you have for shaping the model's most advanced skills.
So for the small LM3 model, its whole education looked something like this. It started with a massive 8 trillion tokens of broad, general data. That's the base stage, building foundational knowledge. Then came an injection stage, where high-quality filtered data was brought in to boost specific skills. And finally, the annealing phase, where they heavily emphasized specialized reasoning data to really sculpt the final model.
This annealing phase really is the final polish. It happens right as the model's ability to learn, its learning rate, is naturally starting to slow down. That is precisely when you feed it the best of the best, the highest quality math, code, and reasoning data you have. It's exactly like a graduate student who, after years of general education, focuses intensely on their thesis to become a true expert.
So, all of this leaves us with a really fascinating question. If creating these powerful AI models isn't some clean, automated science, but is actually a messy, hands-on craft full of manual tuning and artistic judgment, what does that tell us about the future of what we call automated intelligence? Definitely something to think about.